Good morning, good afternoon, good evening, everyone. Thanks so much for joining us. Welcome to today's session. We're going to start out with a little bit of housekeeping, so we're familiarizing ourselves with the tools. If you have questions, please put them in the Q&A, not the chat, but put those directly into the Q&A so that we can go ahead and take those questions at the conclusion of our panel session. We're going to run this track for about 59 minutes. We will get you out of here on time and off to the next session. Most important, to get started, we want to thank our sponsor. This conference and these sessions would not be possible without the sponsors. So we want to thank HighByte for sponsoring this session today. So today we're going to have a great conversation about i3X and UNS, the architecture for industrial AI. And I'm really happy to bring in our speakers to introduce themselves for this morning's session. I'm going to start with Aron Semle, CTO of HighByte and the sponsor of today's session. Aron, go ahead.
Hey everyone, glad to be here. Happy to be here. I didn't know we were sponsoring this until a week ago. That's how behind I am on the marketing stuff. But I'm really excited to have Olivia and Matt here as well. So my name is Aron Semle, CTO at HighByte. My career goes back to 2008, where I started at Kepware for a number of years. Kind of worked in R&D and then into product management, and then moved over to PTC during the acquisition. Worked there actually with Adam for a couple of years. We overlapped there, so it's good to see Adam again. And then I jumped into healthcare for a couple of years, got my butt kicked, and then back in 2020, I joined HighByte, and I'm back in industrial where I belong. So excited to be here, excited to talk about i3X and make it a little more real for folks.
Great. Thanks, Aron. Next up, Olivia Morales, Senior Solution Architect at CESMII.
Hi, nice to meet you all. As Adam said, I'm a solutions architect at CESMII. CESMII is the Smart Manufacturing Institute of the United States, which is a federally funded national institute founded in part to advance manufacturing initiatives and technology, making it more accessible and competitive in the United States. So I work directly with manufacturers and technology providers, advising on architecture, implementation, developer resources to make that smart manufacturing adoption real. I have a background in software development for manufacturing analytics systems. So I think about these smart manufacturing problems kind of from both sides, and trying to make sense of what we should do technically and what works on the plant floor. So i3X is one of those core initiatives. I'm really excited to talk about it today, and teach you guys what's going on there. Thank you.
Great. Thanks, Olivia. And next up, we have Matthew Parris, Director of Quality Test Systems for Industry 4.0 at GE Appliances. Morning, Matthew.
Good morning. Thank you for having me. As you mentioned, I'm the Director for Quality Test Systems. My team takes business requirements for quality factory processes and converts those into software and hardware designs. And then those software and hardware designs turn into equipment that get deployed into the plant floor. And the main purpose of that equipment on the plant floor is to produce data or information that's then used to make data-driven decisions in real time regarding the process, as well as enabling post-process analysis of the production process. So i3X, AI, all of that is definitely relevant to our function within the business at GE Appliances.
Great. Thank you, Matthew. And lastly, I'm Adam Napolitano. I'm your moderator. I'm a partner ecosystem orchestrator at Triple Circle Partners. I've spent about 30 years in industrial technology, industrial software, and I'm just really excited to work with these wonderful panelists to dig into the i3X new offering and get into why it's a great fit for manufacturers. So with that, we're going to go ahead and get started. The first question I'm going to pose to Aron, but Olivia and Matthew, I would love your feedback on any of these, and we'll kind of go around the horn. So first off, Aron, what problems does i3X solve?
Yeah, right at the heart of it. Why are we even doing this, right? The reality is that, and we talk about this in industrial data ops, like the factory is a mess, and that's not to insult anybody, right? We always say like the factory, you've never really had a holistic data strategy in the factory. So I can go into, a large manufacturer and they've got 10 sites and they've got 4 different MES systems, all of which are like mostly homegrown. They got like 3 ERPs. I can even talk to a large company and like, oh, we use Ignition across the board. It's like, okay, cool. If I went into each one of your sites and looked at Ignition, or we could talk factory talk or whatever, am I going to see the same patterns, the same use? And it's like, no, it's different UDTs, different connections, different all customs. This is the reality of what we have. So if I draw a box that is the factory and I put all the different systems we have in there, that's our data today. And it's complex. If I go factory to factory, it's different. If you're familiar, I always laugh, like being a CTO in manufacturing, you can kind of be 5 to 10 years behind IT. So you just kind of peek ahead at the test, look at what they're doing. So you kind of cheat. You can't do that so much with AI, and we'll get into that a little bit. I think the factory's adopting that pretty quick. But back in 2002, Bezos released this API manifesto, I think it's called. Or it was basically a statement that said, you must expose your data over an API. And the gist of that, if you go and read it, is that, okay, we have all these different business units. They're trying to share data, but they're all using their different systems to store that data and move that data. We can't deal with the complexity of all that. But if we can say, keep your systems in the factory or wherever how you want, but expose it over a common API so anyone can access that data. Okay, now we have interoperability and access, and we can make the business more efficient, but we're not making people change or rip and replace, the underlying systems that they're using. And when I think about i3X, I talk about it as the API for the factory, the API for UNS, and it's solving that same basic principle. Now, I don't have to do math on the fly. Now it's 2026, right? So all these years later. But basically, you can think of it as it's a standard API. It's very simple. Anyone that looks at it and goes, why do we need another standard? And then they actually go look at what we're doing. They're like, okay, this is pretty minimal, right? This is just the amount of standardization we need to say, how do we standardize on what we define a motor to be in the factory and how we want to expose that data, or a CNC machine, for example? How do we share common data models? How do we provide access to real-time subscription data on subscription, historical data, the relationships between data, all over a standard API, such that, today we have a lot of architectures where we'll do data ops, we'll do contextualization on the factory floor, we'll publish it out to an MQTT broker. And then what you'll see is if you want to get that data into the maintenance system or the ERP system, you'll see all these little shims. And those shims exist because SAP doesn't talk MQTT natively, right? It talks API natively. So can we standardize on this API layer, this thin layer, wherever we want to put it? I call it the factory API, to help ease those integrations, and also just mature what factories look like in terms of looking more like modern IT systems. Like, we're not streaming out tags anymore. We're streaming out contextualized data that can interact with the rest of the business. So that was a lot, but that's specifically what i3X is trying to target. How do we standardize this API? The truth is, every vendor in this space is doing this today with their own custom API that doesn't serve the community or the industry well. So how do we standardize it such that we get all the efficiencies of a standard API and integration?
Awesome. Thanks, Aaron. Olivia or Matthew, would someone like to jump in and add a little bit to that?
I just wanted to kind of underline one of the things that Aaron mentioned about vendors have solved this problem on their own out of necessity, right? As you said, it's been important to get data off of the manufacturing floor, and to do so, vendors have had to do it on their own, figure out what makes sense, build the infrastructure, define the API definitions. And what i3X solves is that API signature. What are the primitives necessary for getting data off of the manufacturing floor? How do we contextualize it? How do we make it available so that we can actually get value from that data? AI is part of that value. Other applications are another part of that value. So making it available in a common way, in a repeatable way, makes it that much easier to get value from the data, and you spend less time trying to make those connections, trying to wire those tags, and more time actually deriving value.
Matthew.
Yeah, I'm sorry. Another problem in the industry is as a consumer of the internet, I have the ease of use of just opening up a web browser and typing in a URL, and I'm able to get all kinds of information that way to interact with the internet through a standard API, so to speak. It's HTTP and HTML and a bunch of protocols behind that. So I asked the question of why don't we have that capability within our industrial or manufacturing company or across the industry? Why can't I have a single information browser that I can launch on my computer and hit any URL of an application and then just start getting the information that I need. So there's a lot that needs to be commonized or standardized to even get to that level. And that's what i3X is looking to do.
Great. Thanks. That's some really good insight from everybody on the problem statement and why we're here. I want to move to the next question, and Olivia, I'm going to start with you. And why CESMII for this effort? What's the value that CESMII is helping to bring into this valuable problem?
Thank you. Yeah, good question. So CESMII is kind of a unique organization. We are federally funded. We're not a standards body, but we are tasked with enabling manufacturers and helping them achieve their smart manufacturing goals. To that end, we've funded dozens of projects tasked with enabling those manufacturers, investigating how to make the smart manufacturing initiatives possible. And i3X was the result of all of that learning. We realized that not only were vendors solving this problem, each in their own favor, each kind of defining similar APIs, but those weren't interoperable. They still cause data silos. So from our learnings from those projects, we brought together a core group of people to define what an API would look like, starting with a request for comment, putting it out there to the community for responses. And CESMII, being the organization bringing those folks together, we are not a vendor. We are mission driven to enable manufacturers. So we brought together manufacturers, vendors, all together to define what the API would look like. And not just publish a specification, not just publish documentation, but actually build out sample implementations, SDKs, clients that work with this i3X to make it real, to make it functional, to prove out some of these concepts. So yeah, I guess to sum it up, we took our learnings from all these projects that we had enabled with manufacturers and turned it into something that the market could actually leverage and repeat.
Yeah, I'll jump in there and say, as an outsider looking in at CESMII, um, I'm putting words in CESMII's mouth, but they're not looking to develop or create technologies. What they're really looking to do is identify problems and see what's on the market and where the gaps are to solve those problems. And I think i3X is a great example of that, where it's not looking to reinvent the wheel or create new technologies. It's the main purpose of i3X is to leverage what is already working well in the industry across, and there's multiple selections to be made, but just to be opinionated on what those technologies should be that we should use that have already been proven out and that are working. But for us to just commonize and have an agreement across the ecosystem, whether that's vendors or OEMs, system integrators, and manufacturers, let's all agree on what we should be using in a tight, simple stack to access information. And so that's one of the beauties of i3X, is that because it's not new technology, embarrassingly, it's pretty simple, but there's power in that simplicity, as we'll get into through the webinar.
Yeah, and just to add to that, I mean, it's great to have CESMII as kind of the anchor point and the driver of i3X as vendors, right? Because like HighByte and ourselves would not be able to push an open standard well, I don't think, across the industry. And if you look at the vendor list of folks that are involved in CESMII, it's large, right? So there's a lot of interest from small players, big players. So kind of having that Switzerland in the middle that is CESMII, that's able to can take all that input and come out with it's been phenomenal. And I think Olivia, Jonathan, Wise, Jonathan Dyke, Sue Ellen, and others over there. It's just been awesome. When I think Matt and I fell into the RFC trap and we saw it and we started commenting because it's all open on GitHub, right? And then now we're in the working group meeting twice a week, and it's been great.
Yeah, when we put out the RFC, we didn't really know what kind of feedback or responses we were going to get, right? We took our learnings from the projects and we thought we had something, but we didn't know how it was going to resonate or whether it was going to resonate with the manufacturers and technology providers. But kind of the responses came into two camps. It was either uh, folks wanted to get involved and commented, and those folks became part of the working group, or they understood that there was a gap here and they wanted to be able to implement this API and were ready to adopt it as soon as we released it. So that was really validating that we were on the right track and we were identifying and solving the right problems.
Makes a lot of sense. Thanks everybody again. Switching gears a little, and Matthew, moving to you. How does this i3X standard compete with some of the established protocols or players like MQTT or OPC UA?
Yeah, that's a question that we're commonly hearing. Little known secret regarding information interoperability. MQTT and OPC UA actually prevent interoperability. That's a strong statement, but I've written an article explaining how this is. But in short, OPC UA and MQTT are two sides of the same coin, where they leave too much open-ended to allow plug and play or plug and go, plug and work for information exchange. So in the data access model, there's 5 layers that are above the simple transport that you got to commonize or just make a decision on. In the case of MQTT, it only speaks to the first layer, which is the MQTT protocol. Everything else above that is wide open. You can use any encoding. You can use MQTT in any number of ways, and you can define your data types in any number of ways. OPC UA, on the other hand, it defines or makes definitions at each of the 5 layers of the data access model. But those definitions, there's so many options that, again, it's wide open. It's wide open in a specified way, but there's still no way for vendors to know which way, what they should implement within their products. So ultimately, we still are left with an interoperability problem at the software or the plant level. So i3X is looking to fill that gap by being very opinionated about the data access model at levels 1 through 4. So it specifies HTTP, which of course is very common. It creates certain data access methods, which are everybody's going to want, being able to read values, subscribe to values, explore what values are there, and also get historical values. So those are the methods. It standardizes on JSON encoding, and then some simple data types just to communicate the base objects. i3X leaves wide open the object definition layer. So it provides a framework to expose object definitions, but it does not define how those objects should be defined. So an implementer of i3X is able to use any number of namespaces. They can use a namespace that is completely custom, an internal corporate namespace where they have object definitions that are unique to them. They can use a namespace that is globally recognized either through CESMII or the OPC Foundation, or they can use a hybrid of both. So it's up to the information platform to make a decision about the object definitions. i3X regarding object definitions is just meant to be a pass-through, which is part of the power of i3X because there's still much to be done regarding object definitions, such as companion specs or whether that should be globally defined or uniquely defined within organizations. What i3X wants to do is get out of the way of all the grunt work to get to that point, which is wading through what are the communication standards, what are the encodings, what are the different data access methods that I have, what are even the base data types. Once we can get past that, then now we can start to develop on top of information, and that's where the value lies.
I just want to add another, just sort of, Matt used this analogy before, and you mentioned that the API i3X is above these protocols. It's not competing with, and it's sort of like how HTTP didn't replace TCP/IP, right? It was just a layer on top that enabled access to your internet data from browsers. So what i3X does is it augments any of these protocols that allow you to get data off of the manufacturing floor and gives you those common methods to interact with that data, both the type definitions, so namespaces, and the instantiation of that data, which would be the address space. So both of those are provided by the API, which then enables, again, the value creation through API, through applications, through AI, visualization, anything.
Yeah, I think an application doesn't care where the data comes from, whether it be an MQTT broker, an OPC UA server, a REST API interface. An application doesn't care. It just wants to get at the data in a lightweight way that it's able to do natively. So I think that's, yeah, like you said, Olivia, that's the power around the i3X initiative.
Makes a lot of sense. I guess we can move on. And Olivia, I want to grab a question here for you, which is this beta was just announced at Hanover Mess probably about 3 weeks ago. What's that milestone mean, and what can we see in the near future? What's coming next?
Yeah, so we started with a sort of alpha launch even earlier in the year, initial sort of proof of concept, and we had a bunch of vendors develop their demos, and then we had even more demos at Hanover Messe. And what this means is we are transitioning from specification, documentation, proof of concept to something that vendors and application developers can build against with confidence. So, I mean, Hanover timing was intentional. It's like an enormous industrial technology show, and it gave us an opportunity to reach a wide audience and show that we have momentum around this API. And what it means now is folks can start adopting it. So if you're in leadership, that means building this into your RFPs. And if you are in the plant, if you're an OT leader, it's a matter of talking to your current vendors and seeing if they are already adopting or going to adopt this API so you can make sure that your infrastructure is bulletproof, future-proof, and not going to continue to have data silos. Architects and developers, you have a lot of leverage. So start exploring the resources that we have. There is an application that works against i3X. There is sample implementations, and we have a whole playlist of vendors who are already implementing this API. So what's next is adoption, or furthered adoption.
So if you want to mess that up, go onto the GitHub and start posting all kinds of issues, and then Matt, Olivia, and I will have to sit, and John will sit. Don't
Right.
do that. But it is still open though. So if you are a vendor trying to implement it, and you do run into issues, now's a great time to create an issue off the GitHub that the working group will review and make changes if needed. So, but it's exciting. We're getting really close. The issues they've been shrinking over time. So.
That's a really good point, though. We've done all this work in public on GitHub via issues. You can look at our history, you can look at the discussions, you can react to what you see. And we take that feedback very seriously. So
Yeah, I would like to say it's really being run like an open source project is. All the source code, so to speak, the specification, the implementations guide, all that's posted on GitHub, and you can see the history of the changes through time from 2 years ago to today. And you can see all the issues that were brought up and all the dispositions of those. And so it's being run as open as possible, trying to cast as wide of a net across the whole industry to engage people from all walks of life. to be able to put eyes on this standard so that we can solicit their feedback and see what is useful and what's not useful for the various use cases. Because we're not pretending to know everything. It's really the collective effort, and that's one of the principles of open source software is leveraging the collective mindset of everybody that's available to help the initiative. So definitely invite participation to make it better.
Yeah, I'll echo that. I mean, when you get into these types of situations and endeavors, getting feedback, is going to help drive adoption, help improve, make those continuous improvements and refinements, which is what we're all kind of driving for. So I think that's, it's a great opportunity for the community to have a stake in this and be able to benefit from it. So totally agree. And I think kind of building on that, Aaron, to you, when i3X succeeds, what does the future look like? And then kind of tied to that, what's novel about this that's not found anywhere else? So maybe a two-part question for the group, and I'll start with you on that one, Aaron.
Yeah, well, like when it succeeds, right? Manifest destiny.
Yeah.
I think it will. Like I'm very bullish on i3X because I just think it's the right standard, right level of detail. I saw a few questions in the chat. So like the first thing is if you're in the middle of we'll call it UNS build, right? Where you're going to publish data MQTT and you're part of like kind of the classic UNS journey, you're doing nothing wrong. And you're not putting yourself in a position where you won't be able to use i3X. So just to make that clear, this is kind of like to Matt's answer. It's not a this or that. It can be this and that. The part of that that's the hardest when you're doing this is going back to my initial state, every factory is a mess, right? So getting into a factory and actually connecting to the various systems that are in there to put together the data models or the data you want to be able to share and making that available, that's the hard work, right? That's the part where you probably need someone in the plant that understands what's there, understands the systems that are there, how to make the connections. When you go to publish that to MQTT after it's all contextualized, that's valuable, but it's less work. And when you think about i3X, you can think about it as, okay, I make it an interface on top of the factory where now that I've standardized and made all that data available, now I can use i3X to access it. I can also put that on top of a broker just as easy, right? And it'll interoperate and make the data discoverable and readable through a broker to kind of remove those shims. But what does it look like if i3X succeeds? This is where my head's at, right? I'm already like running into the future, and I've been chatting with Matt a little bit on what I'm doing, and he's like, I don't quite get it, and I'm like, no, it's okay. Like I don't know if I totally get it either, but conceptually, what i3X does is it gives us a common API, right, to expose contextualized data like any other IT system. So holistically, you can think about it like, okay, we're taking a step as an industry, be an open standard to make our factories look more like an IT system. If we can do that, more like an IT system to the external enterprise, right? Inside the factory, like we're not going to change a bunch. We still got to run. We still got to produce parts and do whatever. So we're not going to go change that today, but we're going to provide an interface such that when we want to plug this into the enterprise, it looks more IT-like. So what does that mean? It means that a business user that doesn't have a ton of knowledge of the actual factory, assuming this is in place, can start to leverage some of that factory data immediately as if it was any other business data, right? So all of a sudden, if someone wants data off some injection molding machines to do some power analysis or some use case, we're not going all the way down to the factory, talking to the controls engineer that configured the PLC that's communicated with the HMI of the injection molding machine. No, we're up at the i3X layer saying how many injection molding machines are in this plant. I want to subscribe to this data and pull it through, right? So suddenly, and then when you start to think about the AI component, and this is kind of where I'm focused on the data lake side, is like, okay, if I have an i3X endpoint that exposes all the injection molding machines and the metadata, and I have access to the history in the real time, I, as a business user, can just start to prompt my AI, hey, what's there? What does it mean? Da, da, da. And I can trigger off workflows that move that data to the data lake without talking to the data lake and a custom table without talking to anybody in the manufacturing plant. And if you've been involved in anything data ops today or like involved in UNS, you know that is not the world we exist in today, right? We kind of do this, okay, what are they going to need? We package it all up, we send it, right? And then a business user looks at it and goes, not quite what I wanted. Hey, let's iterate. And it's this multiple people, multiple personas that are in the loop. So I think in the future, I think that I don't think we're headed there in a year, right? But I think there is a future where factories come up online like any other IT system, and we suddenly have business users that can self-service on some of the data coming out of these factories without interrupting production and the people on the floor just trying to run the facility. Um, and we're not there today, but I think i3X is a really important standardization step to move in that direction. Um, I think it's an exciting future, and that's novel, right? Like, how would you do that today? You can't, right? We don't really have that today.
Yeah, I would chime in. Take a simple use case of an application and I want to ask the software, tell me about all the objects that are of a defined type, such as a power monitor. So let's say that it's a simple use case of an application that's going to aggregate all the power across the plant. And it wants to identify all the power meters that exist within that plant. So it can start adding up the power and it can analyze who's using the most power. What interface exists for an application to hit a piece of software to query, return to me all the instances of this type? And then after I know the instances of those types, I'm going to query for the latest values, and then I'm also going to subscribe to receive changes to those values. And oh, by the way, let's say that I'm interested in the historical values of those types as well. So all those, it's pretty simple capabilities when you think about it, but I'm not aware of an interface that provides that today. And so that's what i3X is trying to do in terms of being novel, is create as lightweight of an interface to be able to enable that capability of asking a simple question of what are all the instances of a given type, and then to be able to read the values of those instances or subscribe to them or get the history of them.
Another part of the future that I see is just simply more plug and play applications that work seamlessly with i3X. So we don't have a manufacturing app store the way that we have for our phones, for Apple and Android. And so because of that, because there's not a common way to access this data, we don't have a proliferation of manufacturing applications that are easy, plug and play, just connect it, point it to your endpoint, get data out, get value from the application. You have to wire up tags, you have to map to the data source, you might have to aggregate a variety of data sources. And so a lot of time, effort, and money is spent on that integration, and it's brittle. So the future is quicker time to value, getting more insights from your data, and lots of applications that are built against this one API, built against particular types of manufacturing assets or processes, and just simpler architectures.
We got to respond to the GE Predix flashback. I think we've all been around long enough to remember those days and where that comment is coming from. And it's, well, I think it's, I get it. The difference is this is not one company. It's not one massive product with billions to spend, right? This is just an open standard that it will enable both cloud vendors and OT vendors to interoperate better. So I think fingers crossed, they won't end up like Predix, but I don't see a future where that happens. But that's a funny comment. Yeah.
Having
definitely relate to the GE Predix as well.
All right, so maybe changing gears a little bit, Matt. So maybe a little bit of a contrarian question to what we've been talking about. Don't we have enough standards? Why this? Why do we need another? If you want to kind of take point on that.
Sure, I'll try. I guess first off, there's standards, and then there's implemented standards, and those are two different categories. So sure, there's lots of standards that exist that are on paper, and I would say that if they're not being implemented by products, then they're not worth anything. That's a pretty strong statement, but the whole point of standards are to make it into the wild and to be implemented by products. That's where the value of the standard is. And so if standards are not making it to products, maybe they're solving a problem in theory, but standards don't get points for solving problems in theory. You get points by solving problems in reality. And so the industrial information problem, you have to view it as an ecosystem that includes both the OEMs, the original manufacturers of software, in this case, along with the system integrators and manufacturers. And so for standards to work, you need to solve problems for all three of those in the ecosystem. And it's basically an equation of, is the effort to implement the standard less than the benefit I'm going to get from implementing it? Or maybe said in a positive way, or more optimistic, am I going to get a lot of benefit out of this for not much effort? And I think that's where i3X is sitting. So i3X is poised to fill a void that's been present within our industry for 20 years or so, where you don't have a common way to access information from software. You can make a claim that we have REST APIs, aren't that good and isn't that good enough? And sure, REST APIs, again, back to the data access model, it'll solve for the first layer where you've got HTTP, which is the common. And REST does not require JSON, so you're not even guaranteed that. But let's just give it to those that are advocating for REST that JSON is common. So the best that you've got are HTTP and JSON. There's still a lot to be standardized about what options are there. Like a REST API of a given software, that's proprietary. They've created whatever methods that they want and whatever encodings and whatever data types and however way that they wanted to format it. And the system integrator and the manufacturer are at the mercy of whatever those decisions were. They have no bearing on it. And so when you're confronted with multiple pieces of software having to integrate across this, it's work. It's not trivial to do. And so i3X is poised to really commonize that part of the stack so that we don't have to keep reinventing the wheel whenever we go to integrate two pieces of software to exchange information.
Aron or Olivia, you want to weigh in on this? Or I think Matt covered a lot of the ground on that one.
I think it's the meme that everyone sees, like, oh, get all these standards, let's create one more standard to conquer them all. And everyone, I kind of hate that meme because if you stretch that the other way, like we'd all still be using Modbus, right? Like there is a time when technology advances enough that we need to adopt something new. I'm bullish on i3X because I think it's just the right level, the right layer targeting a specific problem. That it will be successful because of that. But I always laugh at that meme because I'm like, well, we just all be using Modbus registers and coils, and I don't think that would be a better world.
Yeah, I'll say that as long as there's problems to be solved, standards are a good way to solve problems. So, like Aron says, all problems have not been solved. There's still more to be solved. And so as long as there's problems to be solved, let's get a standard to solve it.
And I had a feeling that probably a year or two before being in data ops in the space we are, like I felt like we needed a standard. Obviously, HighByte was not big enough, or even today big enough to push a standard. So that was one of the reasons when I saw the RFC come out from CESMII that I jumped on it, because I'm like, this is it. Like this is the piece we're missing, because of all the shims I talked about that we see in reality of like getting data in and out of IT systems that just can't talk OPC or MQTT natively. So yeah.
So we're getting a lot of really good questions coming in, and I know we want to take some time. So I want to hit a couple more with the panel quick before we move to the questions coming in from our group. So just maybe really quickly on this one, Aron, if we put on kind of the architect hat, how should an architect think about i3X and getting into using that? And I'd love to hear the opinions from everybody on this one.
Yeah, I think i3X provides a really convenient interoperability layer between the factory systems and IT systems, right? So you can think about, I draw the box, I call it factory, and then I put a little layer up, I call it i3X. And then north of that is Azure, AWS, GCP, Databricks, Snowflake, et cetera. that's how I conceptually think about it. And it helps because like even our customer base, like the narrative today is C level, we need to do AI, right? And then it comes down to someone that's on the ITOT side and they're like, we're not ready for AI. Like our data in the factory is a mess. We don't have a solid data foundation. Like that's the conversation that's happening today. What that means as a vendor is like customers will come to us and like, hey, we need a data foundation. We don't even know the use cases, but we know we need to clean this up. Uh, i3X is the layer in which people in that situation can say, okay, well, we're going to start to contextualize and build data. We know we're going to expose it over i3X. And we know once we do that, the market's going to catch up and we're going to have interoperability on the IT side. I can build up, and I've got demos of this, like build up a use case where I have an i3X server to model a pharma bioreactor facility or whatever. I can point AI at it and it can use the API to go crawl the namespace, find all the objects, like Matt said, of the reactor type and go build dashboards. So it's a very discoverable, very AI friendly interface, right? And I can do that verbatim. So I think i3X as it matures is going to give you that natural separation between, okay, what do we do factory up? And then how do we connect IT down? And that's where I think it fits best.
All right. Olivia, I want to kind of jump in, and I think this is a really topical question for everyone. So AI hits a wall with data, particularly manufacturing data. Can we talk quickly about how i3X can help kind of break down that wall or those barriers for manufacturing data specifically?
Yeah. And actually, I think I saw a comment in the chat sort of highlighting that industrial AI often fails not because the algorithms aren't good enough or aren't right for this space, but because of the missing semantics, state, and governance. And the question here was, does a well-designed UNS address this? And I think a UNS can help you, but i3X is really the secret sauce to helping enable AI for your manufacturing operations for a couple of reasons. One, as it is right now, a lot of manufacturing data is uncontextualized, not structured. When there is some sort of structure contextualization that is inconsistent then from site to site. i3X in some ways forces you to contextualize your data, right? Give it common names that are semantically significant and create associations with your actual instantiated data that way. So it is repeatable. Your reactors are named the same things. The attributes are named the same things. You're not dealing with tags that are, PLC underscore 1.ai.0145x. That doesn't mean anything to someone who didn't design the system, and it doesn't mean anything to an AI model either. So i3X forces and enables that contextualization that's necessary for industrial AI. It prevents the siloed data from existing, so your AI has access to your data, and it facilitates that data discovery. So with the data context, you also have relationships. You're able to model units, ranges, hierarchical and non-hierarchical relationships. So where does your asset fit within a plant? And then some non-hierarchical relationships like who was operating it yesterday. All of that enables an AI algorithm to go and make even greater insights that a regular application or human can't easily do. So AI is only as good, really, as the data that it has. And if that data is not accessible, contextualized, or trustworthy, then your AI is not going to get value from your data.
I was using the analogy earlier of a web browser, and I think that, again, this is to use that analogy. When you have a piece of software that will get an i3X interface and you start to browse through it or query the information that's there, similar to web browsers back in the 90s, they may look ugly. They may have those very static page with ugly background wallpapers with a site counter at the bottom, and what is this sitemap link? Like, why do I need this? It's going to be a lot of, under construction type GIFs that are got a guy, construction worker. I think a lot of the information that's underlying these platforms are going to get exposed for how ugly they really are. So that's part of the benefit of i3X is it's going to make that more visible, more readily available, so that the end users, manufacturers, system integrators can get to work at cleaning it up, make it look like a web page that's more pretty and more useful to the different use cases.
I will say with all the AI generated web pages, I kind of miss those old under construction pages a little bit from the old web. But your analogy is a great one, Matt. It's going to show you kind of where you're at in your digital maturity. Yeah.
Great. At this point, I think we're getting a lot of really good questions. I think some we've started to address a little bit, but I'm going to go through and pick through some of these for folks and just kind of take them in order as you want to jump in and answer to the panel. So this one I think is a good one to start with. So, given the fact that large organizations like the OPC Foundation have not been able to enforce a comprehensive standard, what's the plan to encourage vendors to adopt i3X?
I'll take a stab at it first by saying I think the strategy for this is to be as lightweight as possible, using things that the software vendors are already using today. So if you make it as simple or as low effort of a lift as possible, then the likelihood of adoption for vendors is high. So for example, if you have a vendor that already have a REST API with HTTP and JSON, and they already have the idea of object definitions within their software, all i3X is asking them to do is to refactor or kind of put on top of their existing API, if you want to think of it that way, to refactor that API to fit within the definitions that we're already doing. So we're not really asking them for additional capability. It's just to retool it in a way that will be common with the way everyone else is using it. And there's already been software vendors that have already gone through that exercise. Ignition, for example, Flow Software, AWS. There's Microsoft through Azure. So there's lots of big players. Aaron, maybe you could speak to Siemens a bit, but there's lots of players that are interested in the value that it can bring and are very interested because it's not that hard to do. And I think that's one of the differentiators is that if your standard is easy to do, then it's more likely to get picked up.
Yeah, and I would only frame like OPC Foundation, not being able to enforce a comprehensive standard. I don't know if that's true. I think at the level of OT, they call it shop floor to top floor. That top floor piece, maybe not as much, but OPC has been tremendously successful in the OT layer. PLC communications and communication HMI SCADA, and that's not i3X is not going to challenge that, right? So that's just back to Matt's initial comments that i3X is at a different layer. It's shop floor to the top, that integration of the shop floor to the enterprise is where OPC hasn't been as successful for all the reasons that, Matt had mentioned. But totally agree. i3X is really simple. And I don't think vendor adoption, and Olivia, you can probably talk to this. Vendor adoption probably isn't going to be our problem in the OT space. I think our challenge is a little bit more on the client side of the IT space, getting those vendors which are very large vendors, to move. But I think we're seeing early signs of that as well. So again, I'm still bullish on but there's a ton of vendor interest, which is great, and end users. Some very large industrials in the states we're talking to are standardizing around or looking to standardize around i3X.
Yeah, I think that is where a lot of the power comes from, the end users kind of demanding or requiring the use of this API. So we're not enforcing anyone. Again, we're not even a standards organization. We're just bringing manufacturers and technology providers together and solving some of these problems. But the way that this becomes a standard or becomes common is through end user manufacturer kind of demanding that it be included in platforms, manufacturing systems, and applications. So yeah, like Aaron said, we've seen a ton of vendor adoption and a lot of momentum there. We're excited to see more and more application adoption from the client side. And yeah, I'm also bullish.
Yeah, on the client side, maybe that is a challenge, but I would argue that it's probably no different than where we are today. So if a client um, needs to integrate to some interface like a REST API, they're going to have to do that integration as they do today. So if they're presented with an i3X interface, they'll be interfacing it like any other REST interfaces, except once they do that, now they can reuse that integration across any software that implements i3X. So it's kind of this idea that maybe there'll be some effort to develop it once, but then once they develop it, now they can reuse it.
Great.
Adam, there's that no common API question from the anonymous. I can look at them too. That might be a good one.
Yeah. Okay.
Yeah.
Yeah, great. So let me go ahead and pull that one up. So there's no common API in IT. Different systems have their own APIs and provide the documentation for it. And this approach has been the backbone of IT. What's the benefit of having a common API versus providing good documentation?
Mm,
Yeah, it's a
good
good one.
question.
I would answer that like, wouldn't it be nice, right? Like if every CRM had a common way to expose its data or every ERP system. Uh, I think what makes our industry a little different is we're kind of starting. I mean, again, we do have our own common API, like vendor specific APIs, right? But it's still fairly new in factories, even to leverage the vendor specific ones. So we're kind of at this stage where like we don't have a lot of data with context today. If we can come up with a standard, 10 years from now, and its leverage, it's going to help us a lot, right? Maybe we'll be ahead of IT for once. That'd blow me away. Probably not. And the other thing is like it's just as Matt as in Olivia, it's just the right level of standardization, right? It's not saying that this is what you need to define a motor as across the entire world of every organization. It's just saying you need a common definition of this thing in your enterprise at least, such that when I connect factory to factory, I'm not dealing with all the differences in how you define a motor at each factory. So I can enable common AI, agentic AI workflows, and common applications on top of that data. That's a great question.
Yeah, I would argue that us and OT, the benefit what we have is we're not as dynamic of an ecosystem like IT is. So IT is across the whole world, across all verticals, across all use cases. So here we're dealing with one specific use case for OT. And so that's pretty well defined of what we need to do. It's not that exciting. It's pretty static. So I think the idea of this allows us an opportunity to commonize that use case so that we can then accelerate integrations.
All right, I think we have time for one more question. If any of the panelists see anything that they'd like to pick up as one of those questions, otherwise I'll pick one. So I think maybe this is a good one because it's again kind of going back to that different standards and different approaches. So uh, to what extent is CESMII and this i3X standard aligning with other existing standards, maybe OPC UA, and then the asset administration shell or others. So if anybody wants to kind of jump in and on that.
Well, we've been very collaborative with the OPC Foundation about aligning this with kind of some existing OPC concepts. Just as a quick example, so one of the features of i3X is to allow subscriptions. And so there's kind of two main patterns in subscriptions. One is MQTT-like, which is I just want to subscribe to the data and get it to me. There's another one that's more common in OPC, which is the server will queue up the changes and then the client will come through a request and then receive all the updates that have changed since the last request. So there's kind of validity in both use cases of subscriptions. It depends on what you're wanting to do. But the kind of through that looking at OPC and how they've done things, we've been able to use those lessons learned. Regarding an asset administration shell or companion specs, again, i3X is completely silent on how you are to format or define your objects. And so it's a transparent pass-through for however you do that. So if you choose to use OPC Foundation companion specs, i3X will pass those through, just like you could through an OPC server. Again, with asset administration shell, that's just another data standard that it can pass through. i3X isn't limited to just the OPC Foundation companion specs, so you can use whatever namespaces you have available to you, whether they're SM profiles from CESMII or your own custom ones as well.
Yeah, if you've leveraged OPC UA companion specifications and you have modeled your data in node sets, then your data is more ready for i3X to make it more available to other applications. But you could use OPC UA companion specifications and other modeling formats that all aggregate the data into i3X and then make it available. So it's a complementary effort.
Awesome. Well, thank you to all the great questions that came in from the audience. If we didn't get to them, we'll work on potentially getting some answers to you after the fact. But to wrap up, I really want to thank Olivia, Matt, and Aaron. Great insight. Thank you for taking the time to answer the questions. Really appreciate the knowledge that the three of you shared. Really want to thank again our sponsor for the session, HighByte, for making this possible and for bringing together these great speakers. We really appreciate the audience for being here, again, for those thoughtful questions and for being engaged in the session. And with that, we're going to get ready to move to the next session, which is From Sensor to Decision, Why Response Speed is the New Competitive Advantage in Manufacturing. So thanks again to everyone. Have a great day and enjoy the rest of the sessions today.